Recording is in progress. Perfect. I don't want this to be on the. Okay. Back to Zoom. Share screen. Oh dear. Okay. I'm just gonna share in this discussion. All right. Does everybody have a discussion? Slay. All right, I'll give it like another minute because I don't want to start early because it's not Berkeley time yet. A picture of your rat? Can I see that? They're gonna be up on. I'm gonna show the screen. You're gonna show it on the Zoom? Wait, I gotta find my Zoom. Nice. Okay, I found Zoom. Should I stop sharing my screen? Yes. Okay. Before we start lecture, we're going to show you a very, very important moment. Okay, does everyone have the discussion notebook opened? Show a thumbs up if you do. All right, perfect. Hi. All right. I should get started, Charlie. Okay.
Are you guys ready for like the cutest thing?
The cutest thing in the world. It's not.
Those are my rats.
These are Charlie's rats.
They're really cute. Look at, they're so stupid. But they're cute and that's so it's okay. Anyway.
All right. Now that we've seen Charlie's rats, we can move on to pandas. Woo! All right. So the way we're going to work through discussion today, I'm going to basically start by like explaining what I'm asking you to do in the question that I ask you guys to do. Let it simmer in your brains for a few minutes, and then we'll come back, talk about it, work it out together. Okay. For the sake of time, question 1A and 1B on the discussion worksheet, I'm not going to go over. I'm going to like skip those entirely. But I will post the discussion solutions on B courses, or I'll put them on the GitHub. And so then you guys can access those. But we also covered lock and iLock pretty in detail last class. So hopefully those should be fine. So to start out with, our first important step that we can never, ever, ever, ever forget is importing packages. So can somebody tell me what packages they think we're going to be using in today's discussion? NumPy. Yeah. So we're going to import NumPy as NP. Perfect. And based on the title of this discussion, what are the other packages that we could be using? Pandas. Yeah, pandas. Oh my God. Isn't that crazy? And what do we import pandas as? Perfect. So I'm going to run that cell. It's going to run. I think it ran. I'm pretty sure. Yeah. Okay, cool. I'm on Colab. I don't usually use Colab, but it should have run on your Jupyter. Yes. Oh, yeah. We're not going to need it for this discussion, but in general, it's good to import it if you know you're going to be plotting something. Okay. So question 1 is all about slicing and splicing and slaying. So slicing and splicing are just fancy words that tell us that like how we're like splitting up and indexing specific parts of our data frame. So it's basically indexing. Same thing we talked about, fancier words, slicing, splicing. We're going to use this lovely data frame that I created from a dictionary. We should all remember how to do that from last lecture. But just run the cell so you'll have access to this dictionary food info. And then it'll give you a cute little Pandas data frame like this. And then, like I said, we're unfortunately not going to do question 1A or question 1B. So I'm going to collapse these cells, but we're going to do question 1C. So in question 1C, I want you guys to add a new column to the food info data frame. And you can use the Pandas documentation to help you find what function, what operator you can use to do this. But I want you to, oh, is this, did I call it fruit info? Oops, that's so silly. No, I typo. I want you to add a new column to this Pandas data frame that's called food info, not fruit info. Food info. And I want you to call it ratings. And then you can put numbers in according to your personal preferences of, I don't know, whatever these foods are. If you think they're like a 5 out of 5, put a 5 out of 5, so on and so forth, your personal preferences. Just make sure you add a column with those numbers. Does that make sense to everyone? Okay, so I'm gonna leave you guys with that for like 2 minutes. And then if you guys have any questions, throw your hands up. Again, use the Pandas documentation. It will be very, very helpful. Yes.
Where you have the list,
What?
do we have access to the list somewhere so we can,
The list of,
the food?
oh, food info is a data frame
Yeah.
that I already initialized. So to that, I want you to add a column of the ratings. That column is something you're going to make on your own according to your personal ratings on a scale of 1 to 5.
But I have to import that one first.
Well, yes, you have to add that column to food info. So food info should be at the top of question 1. So just run that cell so you'll have access to it. Does that make sense?
I don't have
I put it, it's on the GitHub. Yeah. Oh, did I? Ha ha ha. Was I sleepy? Did I put it somewhere else? Did I not put it on the GitHub? That would be really silly if I didn't put it on the GitHub. Yeah, I put it up a few hours ago. Oh, I put it under, yeah, I think I put it under this. Yeah, I see it there. Okay, it's been 2 minutes. Has anyone thought of a way to potentially add a column into a data frame? It's okay if you didn't get around to actually doing it, but has anyone found a function, found an operation, found a thing that you can use to do this? Yeah. Data frame dot insert. Okay, that is one method. Have you actually been able to use it? Putting it in right now? Okay, cool. All right, I'll give you guys till 3:18. Meanwhile, I'm going to create just my array of what my ratings are for these foods, apparently. So. R4, so I have one. Okay, cool. So I've heard that apparently dataframe.insert is one way to insert a column. I don't really know how to use dataframe.insert off the top of my head, so I'm gonna look it up. Let me see. So pandas.dataframe.insert. What do we have to do? Okay, so it says it needs an insertion index and a label of the column, and then the values that I want to put in. All right, seems doable to me. Let's try to use it. Okay. So the name of my data frame is food info, do dot insert. Then what's the first parameter? Location. Okay. So let's say I want it at index 0, 1. Let's put it at index 2. Then column, I want to call this one ratings. And then my values are my ratings. Then I'm going to print out food. Lovely. So that did it. So that inserted ratings at the second index in my data frame. Yeah, perfect. Good job. So df.insert does the job. The way that you could also do this without using dataframe.insert, this will automatically add it to the end of your data frame. So df.insert gives you the luxury of being able to specify what index you're putting this new array into. But let's say that I just want to add it in. It doesn't really matter to me where it goes in. Another way to do this, I feel like this is a more general way to do this. So you could do food info and then open up this thing. This is going to be the name of the new column. I'm going to call it ratings 2 just because I already added a ratings column. So food info, new column name is going to be my ratings. Does that make sense to people? So you can do it using dataframe.insert, but this is also another way to do it. So here we see I have this new column ratings 2 that I just put into the table. But the one thing with this method is you can't pick where you want it to go in your table. It's going to go to the end. Clear to everyone? Does that make sense? Are there any questions? Lovely. Okay. Next part. You can also drop columns. So here what I'm asking you to do is drop any column of your choice from that data frame. So I'll give you guys again a minute or two to figure out what function we can use to do that. I'll ask everyone what function we're using and then we'll walk through it. Also, if anyone at any point already knows what function to use, just put your hand up and then we can go from there. Because then, what's play? Okay, do people have any ideas on how to drop a column from your data frame? Yeah. I did not know that there was a remove function, but let's look it up. Okay, so when I look up pandas remove, pandas doesn't really seem to have a remove function, but look what Google does. Google's so slay. It'll tell me exactly what to use instead. Pandas has a drop method. So that's what we're going to use. Cool. So this drop method, according to documentation, takes in these labels. We know what the labels are. They're the names of our columns. So someone give me one of the column names that they want me to drop from this data frame.
Price.
Okay, cool. So the name of my data frame is food info dot drop. Whoa, I can't spell. And then I'm just going to put in, I think I didn't capitalize it. Oh yeah, you have to be very careful about like case sensitivity. Lowercase and uppercase are very different. So food info. So now if I do that, fun. Oh, it's because I think I have to specify that it's a column. Because otherwise it's going to look for it. Yeah. Well. confusing. Why didn't it go away? Did I do this wrong? Maybe I have to reassign it. Good call. Okay. Thank you, Charlie. So basically what I had to do here, is I have to reassign my data frame food info to the dropped version of food info, like the version where I dropped the column, because otherwise it doesn't like update. Does that make sense? Okay. So that's how you use drop. Very important function. A lot of times you'll be using like really, really big data frames and like you don't really need half the info in those data frames, so you can just drop those columns. Okay, the last part of this question, I want you to basically, all the columns that are left in your data frame, so in my case, it's food, restaurants, ratings, and ratings too. But in your case, it might be something different. But rename the columns of that data frame so that all these labels of your columns are capitalized. Again, there's a function in the Pandas documentation that you guys should be able to find. I'll give you guys like a minute or two to find that function, and like if you find it, yell it out. Otherwise we'll like reconvene and see where we're at with that. Okay, has anyone found any functions that you could use for this? I keep calling them functions. I don't really know. I guess you could call them methods, functions. They are functions technically, but yeah. So like Pandas method, Pandas functions that you could use to do this. Any ideas? Perfect. So, Pandas has a cool sleigh thing called rename. So I'm gonna look up Pandas rename. Right. So now it's going to do exactly what I want it to do, which is great. So it says it takes in a mapper object, which is dictionary-like. We know what that means. We know what a dictionary is. So basically, it wants us to put in a dictionary of key value pairs where the original keys are the keys that are already in our data frame. And what we want to change them to is going to be like the value pairing with that. Okay. So now that we know that, we're going to create a dictionary item. Let's call these, I don't know, like new call names. And remember how to create a dictionary using the little curly brackets. So food is going to become the capitalized version of food. What other columns do I have? Okay, restaurant. It's going to become cap. Can I spell? Okay. Hopefully I'm spelling these right. Ratings is already capitalized, so I'm just gonna like call it something else. I don't know. First rating. And then I'm gonna call things 2. I'm gonna change that to second rating, just for the sake of it being different. Okay. So these are my new column names. And then what rename does is it takes in this dictionary mapper. So all I have to do then is do food info dot rename. And so it's going to take in the mapper specified to the column. So the columns are now going to change into new call names. And if I run this, perfect. No, not perfect. I forgot to do my reassigning again. Cool. Perfect now. So we see that all the column names have now been capitalized. Does that make sense to everyone? How we kind of, also, does it make sense how we can kind of look at the documentation, figure out what the inputs are, and then like create our implementation based on that. So in like all of these questions, I've been like pulling up the Pandas documentation, looking at all these input parameters, and then like being able to use that to put in what I want to do or change what I want to change. So that's kind of the general gist of how you'll go about working with like libraries like Pandas or NumPy or anything of that form. Okay, cool. So that is what we're going to go over in the first question. The second question, what we're going to do is take some time to actually use the Titanic data that we briefly looked at last lecture. So we're going to start by loading in the data. Does anybody remember the thing we used to load in the data?
CSV underscore open or something like that.
Close, right track, but there was specifically a Pandas function that will do that. Yeah. Perfect. So there was this function, I'm going to call this Titanic because that's my Titanic data. And then I'm pretty sure it's pd.read CSV because it's a CSV file. Data.csv. Oh, slay. This is on me. That's so silly. That's so fun. Is it not in the right? Because for this to work, it just needs to be in the right folder, right? In Google.
Yeah.
Fun. No, you shouldn't need to. I'm getting an error because apparently my file is not in the right directory, which is silly. Hopefully none of you guys are getting this error. Okay, so we're gonna not give my Jupyter a break anymore then, is gonna be my strategy.
Oh, it's because you're in collab.
Yeah, then, yeah.
You need to like mount your drive or something.
Oh, that whole thing at the start, yeah. Okay, so we're gonna pretend that none of that happened and that I'm on top of it and that Jupyter is so slay and functional for me today. Meanwhile though, after you guys load that in, while I take a second to also do the same thing, I want you guys to look at question 2A. So question 2A asks, what is the shape of the data set? So shape basically means how many rows and columns are in your data. So like, if you guys know any kind of like matrix stuff, shape is kind of just asking what the dimensions of your matrix are. If that makes no sense to you guys, that is totally okay. It's just asking how many rows and columns are in your data. So there should be a way to figure this out. I'm going to leave you guys with the question of how to figure this out. So do some Googling, try to find a function that does it for you. I promise it's a very easy one-line solution.
It says it on the bottom. You print it, it just tells you.
What?
Like, if you have a function and it's having the string laid out, then on the bottom it tells you what the name is. It says how many rows and columns.
Oh, slay. But there should be a function that specifically returns just the rows and columns. Like I know that when you print the data frame, it's going to tell you the number of rows and columns, but there's also a function that will let you print specifically the number of rows and columns.
And it is helpful to be able to isolate that number.
Yeah, because let's say you want to like iterate through like a number of rows and columns in your data frame or something like that. You want to be able to actually access the numbers, not just like look at them and be like, oh, you know, does that make sense? Okay. Oh wait, actually I should have Jupyter launched already. I'm gonna go here. Okay, has anyone found the function to use?
She found it.
What is it? np.shape, right? Okay, cool. Yeah, so if you use np.shape, it should return exactly the number of rows and columns in the data. Sorry guys, my laptop's acting up a little, but yeah, so that is the idea there. All right, so now we know the shape of the data. What I've given you here is like actually like a breakdown of what is in each column of the data. So you have all these columns. These are all the information that's contained in those columns. So passenger ID is the number of passenger, or like the ID of each individual passenger. So it's a count of the total passengers. Then you have survival. If they survived, it's a 1. If they didn't survive, it was a 0, and so on and so forth with all these features. So what I'm asking you guys to do in the next question is, in this data set, there's a column that shows us how many people survived the crash into the iceberg. What I want you to do is find the fraction of the total number of passengers that made it safely. So find the number of people that survived, divide it, or like, yeah, find the number of people that survived, divide it by the total number of passengers. There is a value counts method you can use if you want to. You could also just like simply choose not to use that. You can also do it that way. But yeah, so take a second to think about how to do this. Okay, cool. Do we have any ideas on how to go about doing this next part? The what? The sum function. Okay, yes. That is a great way of going about how to do this. Going about doing this. I'm sorry, my English is a little broken. So what we're gonna do is, as we looked at the numbers, if people survive, they have the number 1, and if they didn't survive, the number 0. So if you sum up everything in that column, that'll give you the number of people that survived. Does that make sense? Okay. So does anyone remember how to access a certain column? You can use a lock function, yes. So you could use df.lock. Cool. So first we're going to access the column in the data table of all the people that survived. Or I'm going to call them survivors. And then we're going to call a sum function on it. NumPy has a sum function inbuilt, so we're just going to use it. np.sum. And then we would do df.lock. Yes. Right? Yeah. Hold on. Then you have all the rows, and the column name is survived, I believe. Let me see. Let's go to the data. Yeah, so the column name is survived. So that's what I'm going to use. Survived. Is this not lock syntax? I've forgotten lock syntax already.
That's because I always have to look up blocks and that's again. Every time.
Yeah. That's so silly. It's not DF. My data frame is called Titanic data. Titanic data. Cool. So did everyone get this number? Does it make sense how we got this number? Cool. So that's the number of survivors. And then I want the total number of passengers, which is just going to be like, well, you could just kind of look at the shape and say that's 891 because that's the number of rows. But also, if you want to specifically be like, I want to make sure 100% what the total number of passengers are, you can just find the length of the total data frame or the total column that we're looking at. We know we have a length function, so we can literally just throw this into the length function. And then to find the survival rate, it would be your survivors over the number of total passengers. Cool. So that's the chances of surviving if you were on the Titanic on that fateful day. Does that make sense to people? Yeah.
So for the length function, since it's having it go through all the things, shouldn't you also make sure that none of them have like the same name or something? Or they might have duplicated something on the list.
That is a good catch. So you totally could do that. I'm currently working under the assumption that the data is not repeating anything. But if you want to do that, then you're going to have to basically go through the survived column, and anytime like you might have to see like if the name of the passenger already exists, like you're going to have to use two columns. You're going to have to use the passenger name, you're going to have to use survived, and then you're going to have to see if the names like match up, just like ignore the second part of the data or like the second version of that data. Does that make sense? Yeah, so you're going to have to like for loop through it in that case. Cool. Now, we're going to basically look at how we can organize data in our data frame. So what I want you to do in this question is organize the data frame in alphabetical order of the passengers' names. And I want the Z names to start first. So I want to go like from people that have Z starting. Z is the starting of their letter, is the starting letter of their name at the top of the table, and then go down to A. So yeah.
Is it by the first name or last name?
I believe,
The one that's already there?
yeah, I believe there's a column called name. You can just use
Okay.
name
I just want to
directly.
make sure that I'm not having to go through specific indexes of the name.
No. I just want you to go through the column names. Yeah, you don't have to actually worry about like the first letter of their last name or the first letter of their first name. It's just gonna look at like the first letter period, whatever that is. Also, all this data is organized like last name, first name, as a string. So inherently it's going to be by last name, but you don't have to worry about like sorting it specifically by last name. Well, does anyone have any ideas on how to go about doing this? Okay, I'll give you guys like another minute. Things I thought. the homework I wrote out with the one, which is why I put that out. But then I looked at my actual one, it's like, oh, okay. Like I can't cut this up on the spot, like I'm gonna glitch. Okay, does anyone have any ideas? There is an idea in the hint, and that's what I want you guys to use. So has anyone opened up the sort values documentation?
You have to just set ascending false.
Yeah, exactly. Perfect. So what sort values does, it takes in your column name, and then you're gonna basically be able to order your column in either an ascending or a descending order. So in our case, I'm gonna create alphabetical, and then my data frame is called Titanic. What is it called? Titanic data. I'm gonna call sort values. And then I'm gonna call it on my column name, right? And then typically if I just do this, what's gonna happen is I'm gonna get it in alphabetical order, but it's gonna go from A to Z. So like the suggestion we got, there is an optional parameter that you can add in to your sort values function where ascending can be set to false. And now when I run that, it starts with V. So that worked. Does that make sense to people? I'm seeing confusion. So are there any questions about what we did here? Or is it more just like, oh, we're trying to understand it as we're going, so that's why it's a little confusing? Yeah.
Would you be able to do the thing with where you set the third value to -1? Or does that only work with like?
So you're saying like iterate through it and
I guess that would just be, yeah.
okay, I don't know if I'm like understanding your question.
So, because for lists, you were able to, if you want something to be descending, you could reverse the order it looks at
By doing like the
But-
-1.
by doing a -1.
Yeah. So I mean you could. The way that you would have to do that though is like basically iterate through the series and then like add it into a new series
Okay.
by going negatively. Does that make sense? But like there's an inbuilt function. So when that exists, why use a loop? It's gonna do it for you. Cool. So this is how you sort values by whatever you want to sort them by. So this next question, what it's asking you to do is basically find the mean and standard deviation of certain columns of the data. So to save time, I'm only gonna walk through it for like standard deviation. I'm only gonna walk through it for 2 of these cases out of the 4, but the logic applies for all of them. Cool. So first things first, I asked you to find the mean age of the passengers and the standard deviation of the passengers' age. So you guys could take a second to think of how to possibly do that. Should be very similar to something we did a little bit earlier in this discussion, where we used a function on a series. So should hopefully not take you too long to think of how to do this. In the interest of time, I am simply going to do it. So the way that you could do this is call standard stdev of age is going to be np.standard deviation. That's an inbuilt NumPy function, and I can just call it on Titanic data at age. So that's my standard deviation in age. Does that make sense? Just call the function on the column that you're trying to access. Cool. Same for like the maximum number of siblings / spouses aboard. There is a column of siblings spouses called sibs. And I'm just gonna literally call the max function. So 8, that means someone had 8 family members aboard the Titanic alongside them. And that was the maximum number of siblings / spouses that were on with one passenger. Cool. Does that make sense to people? I think this one's pretty straightforward. Lovely. All right. So the next two are a little bit more, I don't want to say difficult. They're just a little, there are a few more steps. So it might take a little bit more thinking to get through it. So what 2E is asking you to do is some people had to pay a higher fare to secure their spot on the ship. So what I want you to do is print out the 10 people who had to pay the most money to be on board the Titanic. And what's going to be a little bit difficult to do is instead of actually getting like the count, so what it's gonna like what sort values is gonna do might return both the name of the person and the count of like what the amount they paid is, but we want you to just find the name, which might be a little challenging, but you should be able to do it. So I'm gonna leave you guys with like 2 minutes to think through how to do that, just because we only have like 9 minutes left. And I want to get through the rest of this. But if anyone has any ideas, shout them out and then we can talk through it and like go forward from there. Okay, I'm gonna start walking through it with just how to find like the fare in the right order. Can anyone like tell me what they think you could use for this? We did go over it a little bit earlier, so exactly. So you want create most fares, and you could call Titanic data dot sort values, and then what would we call it on? Perfect. On fare. And then do we need to do anything else here for it to be in the right order? Exactly. Okay, so that's going to give us a table of everyone, like the order most fares. So this person had to pay 512. I don't know what currency this is in, but 512 somethings. Probably, right? Yeah, so $512 is what they had to pay. So on and so forth. But I also only want the top 10, like the first 10 people. So does anyone know how we could possibly just get the first 10? So, yeah.
It's into a list, but stop once you get to the 10th item.
Like iterate through it and then like.
Well, you just go through from top to bottom on the list and inserting an item, but you have to only go 10 times.
So that is a way you can do it. But you can also just use indexing. Yeah, sorry. Oh, no, it's okay. Go, give me your ideas.
When I looked it up, it said there was a df.head function.
Yeah, so df.head is a function that will display only a certain number of items. So that is a good idea. So if I did this dot head and then a 10, I'm pretty sure that, yeah, so that cuts it to the 10. So that is great. So you can use df.head. That's going to be the first 10. Perfect. That is a great way to do it. if not using an inbuilt function, you can also just like index 0 to 10. Just straightforward index the number of rows you want. But yeah, so df.head or this same function, they'll do the same thing. Perfect. df.head is a great function. Okay. Cool. Now I have this, but I don't want anything but the name column because I don't really care about all the other information. So do we remember how to access a certain column? Yeah, so you can use the lock function. So I'm going to call this most fair names or pairs. So I could do most fairs dot lock, and then I'm going through all the rows, and I want only the name column. Does that make sense to everyone? Cool. So now I have this thing, but I only want, because here I have like this index value and the names value, but what I want is just this index value. The trickiest part of this is to return it as like a list of 10 names. What you can simply do is convert this to an array, and that will literally just do your job for you. And it's going to give you an array of all the names. Does that make sense? I know that last step is a little not very intuitive, but basically, when you convert this Panda series into an array, it's just going to give you an array of all the names, and it's going to drop all those index values so you don't have to worry about them. Cool. I know that was really fast, but if there's any questions, feel free to let me know. Okay. So these next two, we're just going to talk through them all together. So in this question, what I wanted everyone to do is basically get rid of the NaN values because there's a lot of them. NaN stands for not a number, which basically means either the data is missing or the data is like weird, or there's just something wrong with the data. So sometimes we simply just don't want to use, or we just don't want to look at NaN values. So the cabin column specifically has a lot of NaN values. So I want to drop everything that has a NaN value. So the way we could do that is using lock. We can access the cabin column everywhere where it is not a NaN value. Sorry, everywhere where it is a NaN value. Yes.
So for this question, we're specifically trying to get the one, not the NaN value.
Oh, in this question, I want you to print out a data table that only contains the NaN values.
Oh.
So just like isolating the NaN values.
Okay.
Cool. So the way that we can do this is there is a really cool slave function called isNull. So basically, if I'm able to index or access my data frame at the column cabin where the values are null, it will give me a table of the place that all the cabin values are null. So you see how every single one of these is a NaN. Does that make sense? I know that's really, really fast to go through, but what I did is take the cabin column, find where the NaNs exist, and just index at that. Yeah.
Could this be used for all the columns?
Yeah, you could use this for any column, all the columns, whatever. You just need to call isNull on those column names.
But like could you do it without a column name if like all at any time there is a NaN value?
Let's try. Yeah, so you can't do it. Yeah, because you can't do it this way because it's multiple dimensions, but there is a way to do it. I can't walk you through that way right now, but there is a way to do it. You can use isNull to drop all the NaNs. Because basically what this does is returns a bunch of Booleans, and they use those Booleans to like index. So where that, where it is true, it'll like access those data points. Cool. Ah. Cool. All right. This last one, I know we have just a minute, but a lot of times when we look at our data, we want to like have it organized in like groups, according to like what the data is. So in this question, what I wanted you guys to look at is basically being able to group the passengers according to where they boarded the Titanic. So in this case, there's 3 groups, C, Q, and S. And there's a really important function in Pandas that you will see and use a lot of the time called group by. And that's what I wanted you to use here. So what I'm going to do is create a new data frame where my Titanic data, and call this function called group by. And then I'm grouping by embarked because that's like the column with information that I want to make my groups. And then something really important about group by is you have to tell it how to group things. So for example, if you have like a bunch of data and you want to like bin them all together, how is it going to combine the values? So you can combine them by either adding all the values together. You can combine them by taking the mean of all the values. You can combine them by taking a count of all the values. Does that idea make sense? Like if I have 3 rows of data and I want to combine it into 1 row, what am I going to do with the values? I can either sum them all together, I can like find the count of them, find the mean of them, things like that. So you need to specify what function you're using to combine your data. In this case, I just want the total number of passengers, so I'm just going to sum. Okay, I'm going to ignore that error because whatever. But basically, what I've done now is by calling sum, I'm able to group the data by the sum. So this means 93 people that embarked at point C survived. And then 30 people that embarked at Q survived. And then this is the fare collected at each one of those embarkment points. But then you notice columns like age make no sense anymore because now I've just like added in all the ages of all the people. So you need to be very careful like what aggregation function you use because that'll like relate to what information you're able to pull out of your group by. Yeah.
Does it only work with numeric data?
Group by. If you're using sum as an aggregation function, yes. Because you can't sum other objects, yeah. Oh, really? That's interesting. I didn't know it would do that.
There's a group by parameter we can ignore non-numerical values.
Yeah, I'm sure you can also, yeah, there's probably parameters you can put in to ignore things. Yeah, so it's, you see how right now, like my Jupyter's throwing in an error that like it requires like numeric only data. So anything that isn't numeric, it's basically dropping. Maybe like other running versions of Python on other systems are handling it a little bit differently. So that might result in like, if you're adding strings together, I guess it just like throws all the names in one massive string, which also would make sense. Yeah. Oh, okay. I thought there was a question. All right. Sorry. I know I ran through that last bit really fast. So if there's any questions, let me know. Office hours exist. I hope that made sense to people. Have a lovely rest of your day. Thank you guys.